Hello, everyone. Thank you for joining us today. It is just now 12 o'clock Eastern. So I see a few more people joining us, and we'll start here in just a minute. Hope everyone is having a great dosimetry day. Hopefully you got to join the clinic and the therapists and your physicians and physicists brought you lots of treats, treated you extra special today. If you're West Coast and you're just kind of starting your day, I hope you have a great day. Maybe you got some breakfast. Yeah, and if you're still working from home, missing out on all the extra treats in the clinic, don't worry. We got something special planned for you today. All right, we'll just give it one more minute here and then we'll start off with our webinar. All right, so let's go ahead and just jump into it. We have an action-packed agenda for today. So hello and welcome to this very special AAMD edition of our Radformation webinar. My name is Kaylin, and I am part of the customer support team here at Radformation. So as I mentioned, today is Dosimetry Day, so I just wanted to start out by saying thank you to all of our dosimetrists tuning in today. Thank you for everything that you do every day, taking care of patients and also taking care of the clinic. So dosimetry is so much more than just treatment planning. A lot of times, dosimetrists are the glue that holds the whole clinic together, and your expertise in all things radiation oncology makes you such a valued member of the team. We really wanted to just take a moment and acknowledge that and appreciate you and your unique role in the care of cancer patients. So with that, today's session is good for 1 MDCB credits, and the link to take that post-webinar quiz will be available here in this bit.ly link. So you can, just copy that or take a screenshot and type that into your web browser. And then there's also a clickable link in the handout. So in your GoToMeeting workspace or that control center, there'll be a handout section, and in that is a document that will have a link. You can click on that and it'll take you right to our quiz. So after today's session, later this afternoon, we'll send out an email that will have a recording of this along with that quiz link. And so you'll be able to take it there or rewatch any pieces that you missed. All right, so then also I mentioned that we'll be taking good care of you today. So Radformation does love our dosimetrists. And so as a special gift to you for joining, all of our dosimetrists on the call today are gonna get a choice of either a $5 Starbucks gift card or a $5 Dunkin' Donuts gift card. So I'm gonna launch a poll right now and go ahead and just let us know which one of those you would prefer. All right, just give everybody a minute to get that response in. This is the most important part of the webinar today, right? It's getting your choice in. All right, just a few more seconds here. So if you have your audio turned on, but you walked away from your screen, come back really fast. Click your button. All right, excellent. Looks like responses have slowed down. So I'm going to go ahead and close the poll here in just a minute. If you didn't get a chance, just send us an email at the end and we'll get that taken care of for you. All right, so I'm going to close that out. All right, it actually was a kind of a 50-50 split between Starbucks and Dunkin' Donuts. That's really interesting. All right, so clearly we love dosimetrists here at Radformation, so much so that out of our 55 or so employees, 10 of us, soon to be 11, are all CMDs. And because we have such a high number of dosimetrists and clinical staff on our team, all of our products here at Radformation are designed for you with your daily workflow struggles in mind. And then today, I'm going to be talking about auto segmentation and why, if you aren't already using it, you probably should be. So today's session, we're going to talk about the benefits of robots or, automation tools in the clinic, especially as they pertain to auto contouring. With that, we'll briefly go over atlas-based contouring versus AI-based contouring. What are the differences between the two? Why you might want one versus the other for your clinic. We'll also talk about if you do start looking into auto segmentation solutions, how do you evaluate them? What can you do other than just looking at the contours to assess how they are stacking up to your usual manual contours? And then finally, we'll wrap up with a product demonstration of our solution here at Radformation, which we have creatively called AutoContour. And we'll be releasing a new version of that here in the fall. So I'll preview a few of those new features coming in that version. All right, so let's do another really quick poll, not as fun as the first one. But today's theme is kind of, about robots and automation and how that integrates into your life. So with that, what robots are you using at home? So a couple of different options there. And of course, I am using the term robots here a little loosely. What I really mean is, what devices are you using to automate those most tedious tasks that otherwise you'd have to do by hand? And I should have made this so you could choose multiple. So if you have all of these at home, pick your favorite, pick the most interesting one. I imagine many of us have some of these, all of these, wish we had all of these. You can pick your favorite, pick the one that's changed your life the most. All right, so that's a good bit of responses here. Let me go ahead and close this out and I'll share with you the results of that. So yeah, looking like the washing machine has been pretty life-changing for people, but like I said, probably should have made this a multiple or choose multiple there. Yeah, so looks like a number of you currently using any number of those appliances. So our iRoomba, a washing machine, dishwasher, the pool Roomba, that's pretty slick. And then I had to mention this lawn Roomba. So I saw this at Lowe's the other day and I nearly fainted. If you guys haven't seen that, it's pretty cool. It works just like your robot vacuum, but for your lawn. What a time to be alive, really. All right, so the purpose of all of these appliances or these kind of, oops, I didn't close out the poll. There we go. So you can see this lawn Roomba or lawn robot that I was mentioning there. So the purpose of all of these different appliances is that you are going to have the ability to just get through your daily chores as fast and efficiently as possible. And really, that is the heart of what automation is. So you absolutely could do all of those chores by hand. So wash your dishes, wash your clothes, dry your clothes on the line. And some of you may choose to hand wash your dishes. So we're going to stick with this dishwasher theme. But I suspect that the majority of you are happily letting your dishwasher clean your dishes for you. So one of the benefits of using a dishwasher is consistency as well as time savings and quality, or in this case, cleanliness. So if you have any kids or teenagers at home, you know exactly what I mean. So the clean that you get from mom or dad doing the dishes versus your 12-year-old just isn't going to be the same. So those are the same benefits that we get when we use automation solutions in the clinic. So we can power through those tedious, repetitive tasks faster and with less variation. We can move through our day more efficiently. And then the result is that we can deliver higher quality care to our patients. Now, one other thing that really isn't talked about as often when it comes to automation is the quality of life impact. When you are able to spend more time doing things that require your full skill set rather than these tedious low skill tasks, you really just feel more accomplished. So if you spend your whole day printing reports or adjusting care paths, do you really feel as fulfilled as a day spent completing a treatment plan for a difficult case. So we all got into radiation oncology to help patients, and we spent a lot of time honing in our very specific, extremely niche skill set that we're able to do very, very effectively. There's an artistry to dosimetry, and that's really where we should be focusing all of our time and attention. So let's talk about some of the areas in the clinic where we are already automating, even if we don't think about it that way. So your optimizer, no matter what treatment planning system you are using, you have some type of inverse optimization. Now, I grew up in the age of IMRT planning, so I have always known and trusted the computer to calculate a plan for me. But it really wasn't that long ago that all the calculations and plans were done by hand or forward planned. And some of you on this call probably remember those days vividly. You've already lived through one of the greatest transformations in our industry, the leap of faith that the computer could solve the treatment planning problem for you. So some other areas that we're already automating include evaluating the DVH. So Pinnacle has scorecards, RayStation has clinical goals, Eclipse has protocols, or if you're super cool, you can use ClearCheck. We also have automated planning solutions for different TPS, so Rapid Plan, MCO, these things. And I feel like we're really just starting to scratch the surface of that now, and that's going to be a big boom here soon as well. So then a couple other things, we got some automated breast planning tools. So EasyFluence from Radformation or RayStation also has a solution for that. The TrueBeam, so even the Linacs can be automated. The TrueBeam can deliver all the treatment beams without the RTTs kind of holding down those buttons and really engaging with that. Then of course, our QA and second calcs are all automated as well. So we trust these programs to double check all of our calculations. We really have computers checking computers. So automation can be something that we tend to shy away from as dosimetrists. And as I said before, there are so many things that we are responsible for in the clinic. And having all of those responsibilities makes us feel like we are indispensable. But let me assure you that you are absolutely irreplaceable. So think of it this way. Your dishwasher is a great tool to clean your dishes. It will save you so much time each evening so you can be with your family, watch your favorite TV show, or focus on other projects that we don't have robots for yet, like folding the laundry. Seriously, where is that one? I am waiting. However, for the dishwasher to work properly, you have to understand how it works. You have to know how to load it, what settings are most appropriate for the types of dishes that you loaded, and remember to add soap, etc. Then when it comes time to unload the dishwasher, you inspect each dish to make sure you don't have any crusted food or spots or streaks. You are essentially QAing your dishwasher each time you put away dishes. So while the dishwasher is a fantastic bit of automation, it still needs an intelligent operator to make sure it's functioning properly and the results are satisfactory. And just because you have a dishwasher doesn't mean you threw out the kitchen sink. So auto segmentation should really be thought of the exact same way. So at this point, hopefully I've convinced you that auto segmentation is worth looking into if you haven't already started that. And at the very least, I've entertained you with my incredibly long drawn out analogy to the chore that I find most loathsome in my home. Now let's assume that you are going to look into getting an auto contouring tool for your clinic, or you've already started that process. What types of solutions are available and how do you know if they're any good? So the first option is atlas-based contouring. Until recently, this was the predominant way to do automatic contouring, and this works by referencing an atlas of CT scans that you build on your system. So you provide these gold standard contours for various patients. Usually it takes about 20 or so to build a sufficient database. Then when you load up a new CT scan, the software goes through the reference CDs, finds the closest match, and then does a deformable registration, and then copies the contours onto the new scan. So although this sounds like it's a fairly easy to set up and implement process, the reality is many clinics struggle to get their Atlas programs off the ground. So if you have multiple rad oncs in your clinic, getting everyone to agree to these gold standard contours can be a little bit tricky. Sometimes getting just the gold standard contours done can even be a bit tricky. So this typically takes more effort to set up and maintain. But the primary benefit is that if you get your atlases built, you will have these contours that match your particular style. So if you always include the pericardial sac in your heart contours, you should start to see that every time with your atlas-based contours. So overall, this is, I think, just a little bit more straightforward when it comes to understanding how the auto segmentation for that type of contouring works. Now, on the other side of things, AI-based contouring is fairly new, but has just absolutely exploded in the last couple of years. So I think there have even been multiple talks this week about AI and about contouring with AI. So there are lots of different vendor options when it comes to AI-based contouring. And how this works is the vendor acquires hundreds to thousands of data sets with contours and then teaches the AI algorithm how to interpret raw CT data and then contour a new scan that it has never seen before. So this is a little bit trickier to understand from a user point of view, but it's much easier to implement. So most of these solutions are plug and play. And also there's a little bit of trust involved when it comes to these AI solutions that the models have been trained appropriately. And that's why we'll get into how to review these contours in just a moment. But let's say the models are well designed, then they are typically going to be superior to your Atlas-based model contours. So there are plenty of publications out there that have come to the same conclusion that AI-based contours are better than Atlas-based. However, one of the cons of AI is that it can struggle a little bit when it comes to edge cases or anatomy that it hasn't seen before. And then just because you are using AI, I like to kind of quote here, you never know what you're going to get, which sounds a little bit scary, but the truth is when it comes to AI, because it is a learning mechanism, it isn't always super predictable what it's going to get. And the struggle of generalizability with AI is something that we're always working on and trying to improve. And I'll talk about that a little bit more as we get into the presentation. All right, so let's get into how you can evaluate whether the contours are good or bad. And to do that, we'll review a few statistical tools commonly used to analyze auto-segmented images. And don't worry, this is going to be super brief. So here's a quick overview of all the common ways contours can be evaluated. So the different methods here compare different properties of the contours, such as the distances between border edges, the area of overlap, the added path length or border length, and so on. So I'm just going to highlight a few of these in the next couple of slides. So first up is by far the most popular, the dice coefficient, sometimes also known as the dice score or the Sorensen dice coefficient. This allows you to mathematically compare the similarities between two contours. So basically the equation comes down to 2 times the area of overlap between two contours divided by the sum of the two contour volumes. And a picture is worth 1,000 words, so I threw this in here from Wikipedia. I think that really helps understand what's going on there. Now, a similar one is the Jacquard similarity coefficient, or the IOU, intersection over union. Typically, either one of these will be used when describing how auto-generated contours compare to manually drawn ones. So let's go back to that dice score. So both of those, the Jacquard and dice score, are using this scale of 0 to 1, so 0 being absolutely no overlap between two contours, and 1 being an absolute perfect match. So here's a little image to kind of bring that all together. So the more overlap, the closer you are to 1, and the better the contour is compared to that gold standard. All right, so now let's apply that to a CT. For this first example, let's take a look at this breast CTV. So the yellow contour here is our AutoContour left breast model, which we just released about 2 weeks ago. And then the CT and the corresponding red contour is from the 2017 ProKnow Plan Challenge dataset. So really neutral territory there. So let's calculate the dice score by hand. To start, I took the volume of overlap of the two breast contours, multiplied that by 2 for the numerator, for the denominator, the sum of the two individual breast contours. Calculating this out, we get 0.949 as our dice score. So that is really, really excellent. You can see from this image, the dice score numerically reflects the agreement that we're able to see with our own eyes. So for this patient, AutoContour has done a great job compared to the Prono contour. All right, so let's go through one more example, and this time I'll go into a little bit more detail so you could follow along on your own systems. So this is an esophagus contour for that same Prono plan study. So the green contour is the AutoContour esophagus model, and the purple is the Prono contour. So I'm going to start by creating the overlap structure using the Boolean tools and your TPS. So here I have Eclipse, and I'm showing those operations, but you can use whatever you have for your TPS. And then once you have that, you're going to look up the volume of each one of those three contours. So your original manually drawn, or in this case, the pronoesophagus, our AutoContour model-based esophagus contour, and then also the overlap structure. So now we're going to take those numbers, we're going to plug them into our equation, and we get a dice score of 0.75. Which for esophagus, I feel like isn't too bad. That's a really tough structure to contour. And so the main difference that we're seeing for the esophagus here is for the AutoContour esophagus, it did contour a little bit lower down. So right here in this view, you can see this is the primary area of difference. So if you're comparing this to this gold standard, then the dice score 0.7 kind of reflects how this looks comparatively. Now, in your clinic, if you would normally contour all the way down to the stomach junction area, as AutoContour, our model did, in this case, then the dice score would be a lot higher and you would have better agreement visually. And so this is why it's so important to be able to trial an AI contouring solution and make sure that it fits your clinical needs, as well as having some type of objective mathematical way to make sure that the contours look good visually, but also that you have that kind of non-biased numerical approach to it so you can really assess. So when you're evaluating their contours during your trial period, you probably won't want to be busting out your calculator like I did for every contour. And because automation is just what we do here at Radformation, we can't help ourselves. We did include in our software an analysis tool in AutoContour to help you come up with those automatically. So we want to be very transparent about the evaluation process, and this tool can populate data for any contour that uses the AutoContour model. So it will show you the number of slices that you edited, the volume ratios between the original model contour and then what you finally accepted, as well as those dice scores that we just talked about. So here for this example, you can see that the dice scores trended towards the mid to upper 90s. But there are a few outliers, and I would say this is to be expected for AI-based solutions. So no vendor or model is going to be perfect in every single solution for every single CT. So back to that Forrest Gump reference, you just never know what you're gonna get. So sometimes the contours look really, really great, and that's what we would expect most of the time. But just like our patients that have really unique anatomy and situations, every once in a while, AutoContour will just kind of miss the mark. So there will always be a role for the experienced clinical user in evaluating those contours. So to chat a little bit more about AutoContour specifically, we took AutoContour and really leaned into that idea that contours need to be reviewed by dosimetrists, physicians, physicists, whoever's responsible for those in your clinic. And with that in mind, we designed a comprehensive solution that allows you to quickly review every slice of a contour and then make those edits as soon as you see the need. All right, so if you aren't familiar with AutoContour, I'm just going to do a quick background for you. So we do use the cloud for our calculations, which makes them nice and speedy. Generally we can send back an entire structure set in under 2 minutes, but they do contour asynchronously. So as soon as that first contour is back from the cloud, you can start the review process. The data is encrypted, so it is stripped of all PHI, encrypted, and then sent off to the cloud. And then once it's back, everything is deleted from the cloud. We don't keep anything on our end. We do accommodate any treatment planning system. So I know today I've been showing you a lot of Eclipse, but if you have RayStation, Monaco, Pinnacle, whatever, we are able to do 2 different workflows, an Eclipse specific workflow that utilizes the API, but then also a DICOM workflow. So for any other treatment planning system, we still got you. Don't you worry about that. And I'll show you both of those when I show you AutoContour. So right now we have about 65 structures released, and we are cranking on this list all of the time. So as I mentioned, we just released our breast contours along with our axilla nodes, superclad nodes, and IMN nodes. And then these are kind of the things that we have in the pipeline, so things that we're working on. A lot of these driven by requests from our users. So they're things you guys like to see. We have them on our list. So one of the cool things that we can do for our Eclipse users is image registration. So you can either do a side-by-side or an overlay. So if you're contouring, you can still pull in that secondary imaging, your fusions, your MRIs, your PET scans, and use those to help you with the contouring. And then another thing that makes AutoContour fantastic and really unique is this ability to generate planning structures. And I'll spend some more time talking about this, but we can do all of those Boolean operations such as margins, ring structures, overlap, combine, and crop. And then as I said before, we have all of those editing tools built right into AutoContour. So the moment that you see something that needs to be cleaned up, you can go ahead and address it right then and there. All right, so with that, I'm gonna go ahead and just jump straight into the software. So we have here our Eclipse plan. So I'm gonna start off with that integrated workflow, and just bear with me for anyone who is using one of the other treatment planning systems. I'll show you that here in just a moment. So we have that same Prono breast plan. So this is a CT scan from Prono. And I'm going to go ahead and run clear check and then launch into AutoContour. So for Eclipse users, this is our way to go about that. So clicking on that AutoContour icon there. And then as soon as I click on this, this is going to go ahead and package up that CT data, send it off to the cloud for contours. Now, this workspace that we're seeing is Template Manager. And so from this point forward, the workflow is going to be the same whether you have Eclipse, you have RayStation, you have any various treatment planning system. So this is our template manager. I'm going to go ahead and come down to my list of structure templates and grab this breast left template. Now this is going to do 2 things. It's going to add my structures to this patient and link them up with my AutoContour model. So I have all of my contours here. And then I also have all of those Boolean operations. So I can add to my structure templates all of the operations for the structures that I need to create for every single patient. So every left breast patient is going to get a total lung, they're going to get a PTV breast, they're going to need all of these things created. Rather than cranking through those every single time, we'll be able to just generate them very quickly using a 1 mouse button click. So once everything looks good here in this editing workspace, you're going to click on that check mark in the upper left-hand corner. And then we are ready to just jump right into AutoContour. So this is what it looks like. We've got our CT slices here on the left, our structures over here on the right, and then those Boolean operations here at the bottom. So I'm going to sort by status, and now we can see all of the things that AutoContour drew for us. So as I mentioned before, you do have to review every single slice of a contour to either export it back to Eclipse or back out into your treatment planning system. But we've tried to make that as slick as possible. So what I'm going to do is hit the play button here on our first structure. And AutoContour is going to start automatically scrolling through this for me. So from top to bottom, I am not doing anything here, just kind of rolling through this, showing you our left breast and right breast models. And then down here in the bottom of our axial slices, this is now my control center for this approval process. So if these both look good to me, I'm going to go ahead and give it this green check mark. So then that just moves me on to the next set of contours. So here we have the right lung, the left lung, and the carina. So one of the things that you should be noticing as we go through this is one AutoContour will group structures together just to keep that process moving along, keep things nice and speedy. So it's easy to review all three of those structures at the same time. They kind of go together and they use the same window level. So as soon as I came to these lung contours, AutoContour knew that I wanted to see this in a lung window level, so it went ahead and automatically pulled that up for me. Now, if these are looking good, I'm going to go ahead and tag those with the approval, and it's just going to continue to move on to the next contour in the list. So you can also control that review speed. So right now we're at a 3x. If you need to cruise through, we have 5x. If you need to really slow it down, all the way to a 1x. So you can set that in your preferences. All right, so we're just going to continue through these. So we have our axilla up next, capturing all those clips in the corner. All right, so this one's got a couple of ditzels here at the bottom. I'm going to go ahead and just tag that one for an X. I'll come back to that in a minute and show you some tools to clean that up. Up next is our superclav. So by giving this the green check mark saying that this is approved, this isn't going to then send my structure back in an approved state. All it is telling AutoContour that this is approved for export. So this is really just going to allow it to export out into either your DICOM folder or back into Eclipse. Now it does keep this record of what was approved or rejected. So if you ever come back into AutoContour, you'll see all of that information along with in our history tab, who approved it, who modified it, things like that. So really tracking a lot of that information, making it very transparent what the contours have been through on their adventures through this process. So thyroid gland, using the RTOG 1005, you need that thyroid gland, and then our heart contour. All right, so at this point, we've gotten through all of our model-based contours. They were looking pretty good. And so I just want to talk about if you did need to make edits, how you would go about that. So this CTV lymph node for the axilla, towards the bottom here, just a few speckles that, in a 3D probably makes sense. Here on 2D, which we're very much used to looking at axial slice by axial slice, probably looks a little bit funkier. So we do have some tools over here on the left. So we have your paintbrush and pencil tool. We also have an interpolate, a copy paste, and a smoothing. So as you're going through, if some of these are looking a little jaggedy, go ahead and hit that smooth. In our new features for 2.0, so if you are a current AutoContour customer, these are not going to be available to you quite yet, but this is a sneak peek at what is coming. We've added in a few more post-processing tools. So remove parts, we've got a fill structure, and then a threshold tool. So these were some very popular requests from our users. Super happy to go ahead and add those in for you. So let's go ahead and use this remove parts. And I'm just going to go ahead and tell it to clean up some of that axilla where those little ditzels just didn't really, on a CT slice by slice, make sense. So went ahead and just cleaned up those little bits. All right, so now that that is all cleaned up, I can go ahead and give it that same tag of approval. All right, so with that, we have reviewed all of our structures. I can go ahead and export those now. So if I was doing this plan in the clinic, at this point, I'd probably pause, send it back, let the physician review, especially because the CTVs were done by AutoContour. Let the physician weigh in on those and decide whether or not they like them. They can then modify either in your treatment planning system or in Eclipse, and then you can always send it back into AutoContour. It'll take those new versions of the contours, and then you can come in and run your Boolean operations. So down here at the bottom, I have my total lung, a kind of intermediary body structure that I'm going to use to then build my PTV breast eval, and then my lymph node PTVs. So to add a new Boolean operation, you can click the plus button down here at the bottom. And let's say we want a PTV total. Oops. So this is actually pulling that from my structure set above, knowing that this contour already exists, so I don't have to worry about mismatching of nomenclature. AutoContour is actually extremely forgiving when it comes to nomenclature. If you don't have perfectly unified contour names across your treatment planners or your physicians or different clinics within the same system, you can use aliases so that it will still connect everything the way that you would expect. So then for our PTV total, in these sections here above, I've created a lymph node PTV, so combining my axilla, superclav, and IMNs, and then adding a margin to that. And then I'm going to go ahead and take that and merge it with this PTV breast that I'll also be creating. So these have to be in a specific order where they kind of naturally build. So the first thing I have is just a combine of my left and right lung. That one's pretty straightforward. This body intermediary is going to allow me to then crop my PTVs 5 millimeters off the skin. So then you can kind of set that. The nice thing about having these templated is if this is your clinic standard, you can stick with that. But if maybe for this particular case, I wanted to make that 3 millimeters instead of 5 millimeters, I could very easily make those adjustments here on the fly. Our next step here is going to be this PTV breast. So just taking that breast contour from above and then expanding by 5 millimeters, cropping it off the skin. And then for my lymph nodes, as I said before, combining all of those CTVs, adding a margin, and then again, cropping it off the skin if it would happen to poke out. So now I just want to take those PTV breast, PTV lymph nodes, combine them into one gigantic PTV total that then I can either send through my optimizer for an IMRT, or if I have easy fluence, use that as my target for my 3-field or 4-field breast plants. So I'm going to say PTV breast and lymph node PTVs. So nothing too scandalous there. So now all this looks good. I've reviewed my values. That's what I intend for this patient. All I have to do is click this play button here at the bottom. And then just a minute here, we'll see AutoContour go ahead and show me its progress screen as it goes through and loads all of these Boolean operations for me. So if your clinic has these standard things that you're constantly expanding or margins that you're putting on things, you have some clinical guidelines that you follow for your expansions, it is a huge time saver to go ahead, have those pre-populated, make those tiny tweaks as needed, and then just click that one button. All right, so now we see all those contours here. They've got this tag of generated, so I know what was made by AutoContour, what was made from a Boolean operation, and then what's coming from the treatment planning system. So then we can roll through this. So we've got our total lung, just combining the right and left. Nothing too fancy there. This body intermediary was just that helper contour. And then we have our PTV breast trimmed off the skin. And then we'll just switch over to our lymph node PTVs. Just a margin on that. And then our PTV total. And then you can see that for things that were generated based off of contours that were already approved, then these are also already approved. So nice and easy to just send those back to Eclipse then, or your treatment planning system, whatever that would be. All right, so that's how easy it is to come in, run AutoContour, and get those Boolean operations, your margins, your expansions, already ready to go. Also great for opti structures. So if you're creating then a ring structure on this PTV, or, heart minus PTV plus a margin so that you can optimize to this heart that is cropped out of your IMNs. Very easy to do all of that the same way. So you can just continue to add those, and then you can run this as many times as you need. All right, so that was a lot of information there. Let's switch gears. And well, actually, let me just send this back to Eclipse so you can see what that process would look like. So in this case, I have everything. I'm going to go ahead and save it. And then all you have to do is export this. So this is just letting me know that that intermediary body is not going to be exported. That's perfect, right? That was really just for creating some of these other contours. I don't want it in my structure list. So AutoContour also able to keep your Eclipse structure planning list or your treatment planning system contour list a little bit cleaner because you can leave those intermediary contours in AutoContour, not export them out. So go ahead and continue. And then this is just going to export. This is able to leverage that API right back to Eclipse. And in just a moment, we'll see this patient with all of those contours, the same colors and names that you are used to seeing in Eclipse already set up and ready to go. So it doesn't overwrite those. You do have the ability in version 16 of Eclipse to have AutoContour write colors back, but for your other versions, it will just honor whatever was in your structure set. So I would encourage you guys, if you have questions, feel free to write them out in the chat. I'll be answering questions at the end here. All right, just finalizing this export. Good things come to those who wait. And then just as a fun, chat question for anyone who's interested, tell me your least favorite structure to contour. I would love to know. So if we don't already have a model for it, I will, bug our engineers and see if we can't get that pumped up to the top of the list. But yeah, let me know, what is your least favorite thing to contour? Go ahead and post that right in the chat. All right, so then this is just a summary of everything that AutoContour has done for us today. We've created some new structures, we've modified some structures, so just a quick recap. And now we are back in Eclipse with our structure set, same colors and names that we're used to seeing, and then all the structures ready to go ahead and put my fields on and get on with the planning process. Pretty slick. All right, so then let's switch over to this DICOM workflow. So if you don't have Eclipse, thank you for bearing with me with that last example. So this is going to be how it looks for anyone who has any of the other treatment planning systems. So you'll get a DICOM standalone version of our software. So what that means is we'll just go ahead and plug this into your DICOM folder, or you can create a separate folder to pull these scans in from. You'll see your patients listed out here, and then you'll just come over, grab that CT scan or that structure set that you would like. It does show you this preview of your scan. So if the CT therapist has sent over multiple scans, you've got a full and empty bladder with or without contrast, a free breathing breath hold, you get a quick preview of it. Make sure you're grabbing the right scan before you go in and do all of those contours. So we're going to go ahead and launch on a prostate case. So in the last one, I really dived into the Boolean operations. This time I'm going to show you a couple of those editing tools. All right, so for the sake of time, I did run this ahead of time, which I feel real bad about. I'm sorry you don't get to see this live today. If you are interested in seeing this running live with a little bit more attention to detail, feel free to reach out to us and schedule a demo with us. We'd be happy to show you this, run it in real time, show you any specific models that you are interested in seeing. So we have a lot more than what I'll be able to show you today. And yeah, we would love to be able to do a demonstration for you in your clinic. All right, so then in this case, we have a prostate patient. So I've already attached that prostate template, works just the same way as it did before. So on the last one, I said, hey, by the time we get to template manager, moving forward, this will look the same. And here it is. So we're right back into AutoContour, same set of tools and workflow. So I'll just kind of go through this one and we'll look at these models. So the different set of models here, I'm going to sort by status. We have AutoContour at the top. We'll go through our bladder, rectum, and penile bulb for this patient. Everything looking good there. So we'll go ahead and give it that check mark. So next is bowel bag. So right now we offer the bowel potential space or the bowel bag. Bowel loops has been a very popular request, as well as sigmoid, things like that. So those are on our radar. And so this bowel bag is something that, we're going to circle back for in a minute, and I'll show you some of those editing tools. But then up next, cauda equina. So one thing I should mention is you can scroll through automatically on any of these views. So if I just hover my mouse over my sagittal or my coronal, it's going to start auto scrolling in those windows as well. All right, so then we have femurs, right and left, showing you both of those at the same time. All right, so I want to take a moment here when we talk about femurs because I had talked about in the earlier part of my presentation, these models and not being able to necessarily customize them to your particular clinic's workflow and what you're used to seeing with AI based. So with Atlas based, yes, with AI based, a little trickier because they are pushed from the vendor side of things. Here at Reformation, though, we feel very passionately about giving our users what they need when they are doing patients in, treating real patients in the clinic. So when we originally rolled out AutoContour, these were our models, and the feedback that we got from users was this was a little bit long for a femur contour. So we took that feedback and we pushed new models. So we're going to have, oh, sorry, scrolled too far here, the femur with the RTOG definition. So this is really going to stop at the lower trochanter, right at that ischial tuberosity in the pelvis. So now you can choose which femur contour you want to use in your clinic, and we will continue to build those customizations and those alternative models as they're requested by clinics. So there are a few of those that we have already. We offer a spinal cord, a spinal canal, we also offer an inner ear versus cochlea, and then we just pushed that femur following the RTOG model versus that more generous and longer contour. So we got kidneys and pelvic lymph nodes. So at this point, we have our breast CTV, our lymph nodes for the axilla, IMN, superclav, and then also pelvic lymph nodes. So really starting to chip away at those CTV volumes. Prostate and seminal vesicles in here as well. So if you're a dosimetrist that you're interested in AutoContour or an AI-based solution, but specifically AutoContour, I would hope, that's a great way to maybe get your doctors on board, letting them know that, hey, they can also do some of your CTVs and how easy it is to work collaboratively with the physician in this space, tagging those approvals, those rejections, accepting edits. It does make the process really nice and simple. All right, so let's circle back for this bowel bag. So I flagged this one as still needing a little bit of work. So there's kind of two ways you can do that. You can either give them the rejection, and the rejection would then prevent this from going back into your treatment planning system. So if I left this in a rejected state, when I exported this out, it would not send this bowel bag contour. I flagged it here as a rejection, just as a reminder that this needed to come back and be edited. You can also edit on the fly. So right when I saw this bowel bag needed some work, I could just stop everything there and do my edits. So there are a couple different ways that you can handle that. So let's say that I just want to clean up this bowel bag contour. I think one of the biggest struggles with AI-based contouring and really implementing that wholeheartedly in the clinic is when the models don't look good for a particular patient, cleaning them up in an efficient way. So here at Reformation, I think we designed a pretty nifty tool for that, and that's going to be our recent edit interpolation tool. I'm going to show you how that works here in a minute, but I'll just kind of explain it up front. So currently, if you get a contour back that looks a little junky, you really only have a couple of options. So you either edit every single slice, which takes forever. You edit a slice, delete a couple of slices, edit a slice, and then go back and interpolate where you had deleted. or you just delete the whole dang thing and start over because it takes so long to edit it that you might as well just draw it yourself. Here with AutoContour, with that recent edit interpolation tool, we're going to be able to quickly apply our edits to slices that we skip. Let me just go ahead and show you that. So I'm going to go ahead and activate that paintbrush. And I'm going to hold down my shift key to activate the eraser. So if you're an Eclipse fan, this is going to be all the same tools that you're already used to. If you're not used to those, up here in the upper left, just a quick reminder what these will need from you to get them to work. And so I'm going to edit a slice, just kind of crop this out of the liver here. I'm going to skip a couple of slices and come and do another edit. And depending on, how drastic the edits are, you can go quite a number of slices in between and still get really good results. All right, so I won't bore you with the rest of my contours here, but you kind of get a feel for what happens. So we edited every couple, and then we're going to come up here and just hit this recent edit interpolation. And then you can see that it overwrites all those contours in between, intelligently applying the same style of editing. So if you do end up with a model, it's a slightly less than stellar job, editing it is a very simple process, and you can still salvage it and not waste a whole lot of time cleaning it up. Huge fan of that tool. All right, and then just the last thing I wanted to show you very quickly, I know we are running out of time, is you can still use that tool in a slightly different way. So for bow bag for a prostate case, right, bow all the way up to the diaphragm, probably a little bit excessive. So I'm just gonna come in here and say, clear this from my top slice, come in somewhere around maybe like L5, that feels a little bit more reasonable, clear here, and then just hit that recent edit interpolation, cleans up everything in between, and now I've got a much more reasonable bowel bag contour for this particular patient. Tag it with that approval. Everything looks good there. I have my Boolean operations already set up and ready to go. So at this point, I'm able to pull the doctor over, say, hey, I have my CTVs, the prostate, the pelvic lymph nodes, seminal vesicles are all contoured. What do you think? You can have them sit down and say, oh yeah, everything looks good. And then you have your CTV expansion, PTV expansion, as well as some opti structures, some ring structures, some rectum avoid structures. Just go ahead and hit that play button. It's going to generate all of these for you. And then this one went a little bit faster. The contours were smaller. So then we have all of those structures also ready for review. So you can go through all of these, make sure they're what you are expecting, what you'll need for your optimization and for your planning. And then similar to before, you'll be able to just export those. In this case, it'll be a DICOM export, and then you'll go into Pinnacle, into RayStation, into Monaco, XEO, whatever you have, import this, your CT, your structure sets, ready to keep going on with that planning process. All right, so hopefully that was a really, a good overview of AutoContour. And also just more generally, auto segmentation, why it's so helpful, what we're trying to do with automation and how it can really elevate you as a dosimetrist, as well as a couple of skills then. So once you do start evaluating these auto segmentation tools, how to evaluate them. So on that line in AutoContour, I showed you that analysis window. Here in the show history, you would come up here, choose your structure, and then click on this analysis button. That's how you're going to get into those dice scores and everything there to really analyze how AutoContour is performing for you. All right, so then with that, I just want to take one more moment and shout out all of my colleagues here at Radformation. So I said we had a ton of dosimetrists here at Radformation. I just wanted to show everyone's faces up here and tell them how much I appreciate them as colleagues. We have a great team here at Radformation. Love working with all of these lovely people. And yeah, one more thing, we're looking for more dosimetrists. So if you are in the market for elevating your career, if you listened to Montreal's presentation yesterday from the AAMD webinar series, he did an amazing job talking about how we can move up in the space. And I think, working at Radformation is a great way to kind of expand your skill set and feel like you're making an impact on a big level. So we have all different job postings available right now. We're looking for dosimetrists across a couple of different positions. So check us out at radformation.com/careers, see what we have available. Of course, if you're not already following us, feel free to do that. If you have any questions about today's session or you want to take a look at AutoContour, you can reach out to us, support@radformation.com. And with that, thank you. Thank you so much for listening today. Thank you for everything that you do in the clinic on a daily basis. It's just amazing work. I think dosimetrists are so special. I feel blessed to be a part of that group. So yeah, I'll take any questions that you guys have at this point. All right. Any All right, so the question box is a little bit small. Let me just go ahead and pop that out so I can see it. Few questions here. All right. Yes. Okay, so a few things I do want to answer here for you guys. The first one was, what version of AutoContour am I using? There are a few contouring tools that we don't have. Yes, you're right. So today I showed you a preview of our 2.0 version, which is coming this fall. So don't worry about that. You're not behind, not yet. So we haven't released those yet. Today was just a sneak preview. Can you save the edited contours for the MD to review at a later date? Yes, absolutely. So you can hit the save button in AutoContour, and then anyone else who launches AutoContour will be able to pick up right where you left off. So if you reviewed the OARs that you felt comfortable with, and then left maybe like chiasm, brachial plexus, and the CTVs unchecked, you didn't reject them, you didn't approve them, and you want your physician to come into AutoContour and review them themselves, I think that's a fantastic way to use AutoContour as a communication tool among staff members. So these have been reviewed, these haven't been reviewed, these have been reviewed and rejected, whatever that combination is going to be. So as soon as, dosimetrist closes out, physician launches AutoContour, they'll pick right up where that person left off. Is 2.0 when the adaptive brush comes out? Yes, and I forgot to show that the dynamic brush as well as the rubber band tool. So if you're a pencil fan and you like being able to push and pull on those lines, that will also be available in 2.0. Uh, yes, an idea. So feature requested here to adjust the brush size. So adjusting the brush size can be done by right-clicking your mouse and then sliding right to left, which I just learned. I'm actually embarrassed that I've been a dosimetrist for 10 years working in Eclipse and I didn't know that before. But yes, that'll work in AutoContour. Another question in here is kind of more of a support question. So if you are using AutoContour already, sometimes you run into this issue with the recent edit interpolation that it says no slices to interpolate. Why is it doing that? That's a great question. So the recent edit interpolation brush is a little bit sensitive to the order of the edits. So my recommendation is just starting at either the most superior part of your contour or the most inferior and working in one direction. So if you kind of work halfway through the contour, then you go back up and then edit something and then come back down, it gets a little bit confused there. But in 2.0, we're trying to make it a little bit more intuitive and then also make it a little bit more forgiving of that type of editing style. Yeah, what other questions do you guys have? These are great. We just have a couple minutes left and I love getting your feedback, your questions. I appreciate those who wrote in about their least favorite contours. All right, so that looks like it's everything. So thank you so much, everyone, for joining today. Keep an eye out for those gift cards, and thank you for everything that you do. Happy Dosimetry Day, and enjoy the rest of your day.